Hi, this is YuZhang, and this is my code walkthrough for the final project. Firstly, I want to show the overall framework of the project. Like I have explained it in previous in previous class, there are three major components of the overall design of the system. The first one is the physical component, which is the flexible object and the particle. And here I use beam and the particle as the class name for the two categories of objects. And on the other hand, I have the main computational logic contained in the force engine, which is used to calculate force, and some helper functions contained in utility class. So these two classes will mainly be used to support the calculation of the system, meaning they are handling all of the mechanical logics of the system. The third part is the interaction component, which is the system and time marching component. So these are the these classes will be used to contain the physical object and having interaction with all of the force generators to help pushing the system, the all configuration of objects from the current configuration to the next one. So, and then the code, once this framework is being defined, designed, and the code is pretty much following this procedure. So this is the current status of the code. It's not completed yet, and but the overall framework has been done following the structure I showed before. So firstly, for beam, this is one of the physical components. For the beam class, I have all of these private properties defined to describe the physical, mechanical properties and geometrical dimensions, along with some properties used to compute, formulate the final difference description of the flexible object. And corresponding to that, I have the constructor, gather center methods used to define the physical representation of the beam. And so the second class is the particle. It's not completely designed yet, but it will contain almost similar information as the beam object. So here, what I want to point out is beam objects and the particle object are designed to contain the bare minimum logic with only some properties contained with very little information, very little computation involved to generate force, etc. That will be handled in the mechanical computation logic. And then I want to show the force generator. So far, I have implemented the computational logic for gravitational force, elastic force, and distributed force, external force. And these are the codes for each of the components. So here, by the way, just to mention for the C++ code, I'm using Eigen as Eigen library to help me implement the linear algebra component of the system because it's much easier. It will be much easier and much more efficient to use a well-established framework. Because of that, all of the vectors are defined in the sense of this Eigen library. The mathematical backgrounds of the mathematical description of all of these forces have been discussed in previous lecture, but previous presentation. And here is just how I use the code to calculate all of the detailed information like like geometrical gravitational forces. And this is how I will calculate the elastic forces. It will be based on the configuration of the beam and using Gauss integration to integrate all of the detailed information to formulate the elastic force. So that's pretty much how force engine is designed and work. And so far, this is what I have with the code. In the future, there will be implementation in the system, in time marching, and utility. I have some utility functions, such as this helper function, help me to get the Gauss, to do Gauss integration. And this one is to compute the shift function of the geometry of the beam to help me get the geometry of the beam for finite element method. So that's pretty much what I have with the code. And again, this is just temporary. There will be more implementation of the code in the future design. Okay.